Our next presentation, two gentlemen from Lockheed Martin in Denver, Steve Girali and Ian Rousom, and they are fellows in the Space Division talking about intelligent factories of the future.
So I just want to say thank you for the opportunity to share Lockheed Martin's perspective on the promise of our intelligent factories, what's driving these investments and why these investments are critical to produce results for our most demanding and critical programs. So today, my name is Ian Rousom, and I am joined by Dr. Steve Girali. We are in the space business area, but we work across multiple business areas in our role as Ellen Fellows in the digital factories, digital transformation, and similar efforts. So we have a lot to go through today in a short time, and we want to save plenty of time for questions. So we'll go right into this. Lockheed Martin is the largest defense contractor and systems integrator in the world today, and we have a very, very diverse portfolio in defense, civil, energy, cyber, and many other fields. All of our business areas are actively building more intelligent factories in support of not just more affordable, faster product delivery times, but a better integrated multi-domain portfolio. And we can really only do that, deliver such a diverse product portfolio with a diverse world-class workforce. We deliver our solutions all over the world, throughout the United States and to allies, and we do that in, increasingly digital ways. Doing that efficiently demands virtual collaboration, digital delivery, and digital thinkers. So we talk a lot about digital. We do an awful lot of research in what you might traditionally think of as a defense contractor's job, but a lot of what we do is in how to interconnect our systems, how to do more information exchange across different platforms, and of course, how to build systems of the future. And here's just a sampling of some of the statistics of the size of what we work on and the breadth of our portfolio. But again, we keep mentioning digital. So what do we mean to be a digital organization? What does digital transformation mean? Now, this chart here is how we look upon this, regardless of which business area we're talking about. Digital is really another industrial revolution. The first two revolutions focused on how we could make certain things or what we could make, how quickly we could make them. Most of the industry is still somewhere between the third and the fourth revolutions. The third one lets us do more work with fewer people and to let the people work on less mundane, less repetitive things. But really that third industrial revolution of computer and automation still is focused on digital paper. So taking paper processes and making them more accessible, whereas a real digital transformation involves doing the work in a digital model, doing work in a purely digital way without keeping legacy paper processes around. And there are a lot of examples of how this is done. Here are a handful of the ones that are, these are the biggest challenges, but also the biggest opportunities we feel. Digital twin is really a matrix-like experience, you might say, of where we have such a strong, compelling copy of a real thing, a real system, a real environment, that the digital model is accepted as truth of what the physical thing that will actually work in the real world would do. Intelligent factories, this is the focus of this presentation, deliver digital twins, and they don't just do that with software and with code. We have to know a lot about what's actually going on with the machinery, interconnecting them, taking data from all of them to optimize their operation, their maintenance. We do that in conjunction with a data refinery. So you've often heard the expression, data is the new oil. Now, instead of having stovepipe or siloed data, we want to process that data in a common context. We need to share that data, make it accessible to manufacturing engineers, aerospace engineers, really all technical roles to better understand what is really going into the factory, being done in the factory, coming out of the factory, and what are the implications of what the factory did once a system is in the real world. And then last, we have that control tower. That control tower is really important, especially with this diverse portfolio that we have. And the key with that is it's a central hub. We don't have lots and lots of little towers. We need to have one point of awareness that shares all kind of data. Now, what do we need to keep all factories going? How do we make sure that a slowdown in one factory doesn't affect all of the others, that we don't have problems in the supply chain? And that's about far more than just making information available. It's about making the information available in the right place at the right time. So here's some examples. We have an example here from each business area on how we are doing transformation. Each business area has a handful of programs in it where we are really going all in on digital processes and eliminating as much just electronic paper as we can. We use technologies like AR and VR to go through a process, an assembly process, a test process in ways that would be much, much slower with a physical mock-up of a system than a virtual one. We use those techniques for not just building, but also designing, maintaining, servicing different systems, regardless of which domain, land, sea, space, air that they happen to work in. Digital innovations in the factory have saved an awful lot of time in all of our manufacturing lines, especially some of the largest ones like the F-35 line, where by keeping track of every part, every supply chain, every process that works in the factory, we find things that were happening that we didn't really even know were happening. And when you take even small improvements and multiply them out over a program the size of F-35, that adds up to really big savings in time and money. So there are a bunch of other examples we could go through here, but the key is it's all about the data. It's not so much about the business area or the product or the domain, but it's all about putting more data into more of our factory processes. Now, we feel that continuing to use data is very, very important, and we are very proud of some of the firsts that we have here with cloud computing partners, partnerships with supply chain, partnerships with others in our space to really deliver value to our customers faster, to do things at a millisecond scale rather than a days or weeks scale. And none of that is possible without a lot of insight into the data. There's a strong connection in building an intelligent factory and the crossover between OT, operational technology, and IT, or information technology. The line between those should blur if we're doing this successfully. So before I turn it over to Steve, just one more note. Industrial Internet of Things, or IoT, is a term you'll see a lot over the rest of this presentation. IoT is about a whole lot more than just machines and supply chain and getting information from the factory into a server somewhere. It's about a connected ecosystem of things that help us do factory work more efficiently. If we know what is going on at different points in an assembly line, if we know that a step, 17 steps back in a process causes us to do things repetitively where we are in the process now, well, in the past, with previous assembly lines, we would change things once and hope for the best. When we have connected systems, connected people, we can do continuous improvement in the factory, much like we've come to do continuous improvement in software. So you can think of IoT as an enabler of using software development techniques in physical manufacturing. So here's an example from one of our factories that shows the effects of this. This is one of the final assembly steps on an aircraft where this was previously a manual operation, measuring, painting, making sure there were no scars or other defects. and this process is now completely digital. So with that, I will pass it over to Steve.
Thank you, Ian. One of the areas that we kind of wanted to show was a little bit about our journey and how we kind of started to work on this intelligent factory for the future. And you can kind of see it started about 2017, 2018. We started setting up cross business area teams, started developing the requirements, developing, our request for informations with vendors to see what the art of the possible was, and started getting demos to see what we could do to deliver a capability for the corporation as a whole. As we kind of went through that effort and started defining the architectural components that would go into it and the standards we wanted to leverage, we kind of started to walk into November 2018, where we hit AWS reInvent and some of the capabilities that they were trying to do with IoT devices, and wanted to partner with them to leverage their capabilities to start bringing online our systems and data to start doing the analytics that Ian was talking about. It really kind of came in 2019 where we wanted to start proving out the capabilities. So we call them JDIs, but these are just do it events. This is where we actually apply the physical technology to the problem and see the results that come thereafter. Once we kind of gained success there, we started doing lots of JDIs across all of our business areas to really prove out what those capabilities could look like for each one of them. As we kind of moved later into the late 2019 phase, we started getting kind of that success is contagious realm, where we started getting more and more devices across multiple business areas kind of brought online and starting to test out those capabilities. You'll see later on what our roadmap looks like for the future. So if I go to the next slide, the next slide basically shows you, and this is actually a video, what the concept is of a digital twin within that industrial Internet of Things devices. On the left-hand side, you actually see the physical device. This is a conveyor belt. This conveyor belt we've digitally represented. You can see it on the right-hand side where we're showing it in a VR concept. As the conveyor belt moves, so does the belt itself, right? We have other things like cameras hooked up on these things so that we can actually look as material moves across those conveyor belts to look for any defects or issues. We can also control this device with our voice, with also IoT wearables, buttons and things of that nature for people to kind of control things, and started to prove out to our leadership team what we could provide in relationship to capabilities and being able to show how the devices could connect and be visualized. This kind of shows you the roadmap for the future. So as we started to connect each one of the business areas, as we kind of came into 2020, we started looking at how can we start bringing analytics into all of this and doing dashboards and reports, and I'll show you what that looks like here in a moment. We also wanted to start connecting lots more machines. You can see by the fourth quarter here, our goal is to get up to 500 industrial machines across all of our different production environments enabled and connected. That also means that we want to create those digital twin representations of that equipment, being able to show HMIs or human machine interfaces to interact with that equipment through digital screens. We also want to start bringing on international sites, providing other tools, tool types into our environment that we can control and manage, and supporting greater automation, just like what Ian was showing you on our aeronautics product lines. Within space, which is the area that both Ian and I support, you can see the business areas that we have: military space, commercial and civil, strategic and missile defense, special programs, and mission solutions. Overall, all of these programs support many of the government federal entities. You can see how many employees we have, about 18,000 spread across internationally. You can see what our sales look like over that time period. So when we talk about that real-time monitoring of industrial machines, it's really taking that spacecraft. So you can see right here, this is a missile warning satellite, and being able to put sensors in as it goes through the manufacturing process to be able to monitor and manage it as it goes through all of its life cycle processes. So we do things like condition-based monitoring, where we're looking at the device as it's being put together, as it's being tested, and other things to make sure it's meeting the given quality constraints. We also wanted to be able to have a federated data storage model where we could bring all that data together into a single place where we could do analytics off of it. We also wanted to have common AI algorithms that we can use across the business areas to do anomaly detection and other types of efforts. We also wanted to have the ability to do dashboards and reports so that we can actually see how our production shop floors are working and operating, and also support any of the automation capabilities in trying to automate as much as possible through the manufacturing and quality test cycles. To look at the actual business case and how we deployed it, this kind of walks you through it. We have in step one a set of devices. These are CNC machines that cut out parts of material. They're 3D printers, they're lathes, they're all sorts of different things. We also have those devices connected up to a Kepware server device. This has a set of drivers to be able to read all the sensor values from the actual industrial equipment itself. We bring that data in, we connect it to AWS IoT Greengrass, where we actually transform the data into a common data format. We use AWS Lambda to convert that data into that common format, and then push the data along from our isolated network where these machines lie into the actual AWS services themselves. In this step, you can kind of see the data traverses, through our firewalls, through our proxy servers, and out into Amazon directly. Amazon has an IoT Core component that basically allows us to intercept all of the sensor data and then be able to perform transactions against it. So you'll see here, we have three ways that we process data. The top way is where the data actually streams in. So in steps 8 and 9, we stream data into our advanced analytics environment so we can do anomaly detection and things of that nature. In the middle box in step 10, we actually have a data store for storing the hot data so we can pull the data back out for reporting and other types of efforts. And then we also have a data lake in steps 11 and 12 that basically allow us to store that kind of cold/warm data so we can do historical analysis off of it. What happens is, as we do that kind of anomaly detection, what you'll see here is we get to a place where the operators, the operational technology folks, get notified if there's an issue or a problem. They can get, in step 13, get any type of notification going forward on that. In addition to that, we also provide a set of reports. You can see Tableau down here in step 14, where it can connect either to our hot data stores or into our data lakes to actually pull data and reports about how things are operating overall within the production shop floor. This shows you a little bit about what that data kind of looks like. You can see the format on the left-hand side. It comes out as a JSON message. It basically identifies the sensor, the value, and the timestamp on when it occurred. And what we do is we take all that data and transform it into a standard format that we use called MT Connect in order to standardize across all of the machines that we're collecting data from so that we can do reporting and analytics off of it. When we get to the advanced analytics, what we try to do is we leverage a custom anomaly detection solution. It basically looks at what's nominal behavior for that item under test. It observes that normal behavior. And then what happens is we actually run real data in, and it uses an unsupervised machine learning algorithm to identify, okay, is this normal operations or abnormal operations? And when we receive kind of abnormal operations, either during a manufacturing cycle or a test cycle, then we pause the operation to go and resolve the issue or problem. This kind of shows you other examples of where we're actually taking some of these machines and starting to digitize them on the shop floor. This is a Mazak CNC machine used for cutting out parts of material. And you can see on the left-hand side shows the real device. The right-hand side shows it actually in that kind of VR concept. We can then start to overlay on top of it any sensor values or objects that are important to the shop floor operator about what's happening with that device. Just like we said before, it's all about the data, and the data is critical in order to determine whether or not we're running optimally. So we actually build out a set of reports and human machine interface visual representations on how things are operating. So on the left-hand side, you'll actually see the reports where we're looking at all of our milling machines and how they're running over time and how much of them are being utilized so we can share that capacity across each one of our business units. You can also see on the right-hand side our human machine interfaces, where we show you the different types of devices, the sensors that are happening with them, and allow you to control those as well remotely if you need to. So for the business outcomes, what we wanted to do was to show you some of the stuff that we were doing in regards to deep edge, where we're actually deploying servers and services to collect this information, to stream it in, and actually process it. We also wanted to show you how we manage those devices, gain that kind of data-driven insights to do reporting and analytics off of it. We have built-in security so that we lock it down for both users and devices. with protected environments in both areas. Obviously, since we're using Amazon, we have the ability to kind of pay as we go in regards to pricing. The more devices we bring on, the more that we'll pay. So we just scale that as we scale out the actual functionality of the system. Obviously, we wanted something that was scalable, responsive, and reliable, that it integrated across other services, and that we could build our reports and analytics on top of that. So this kind of shows you a little bit about what we were able to accomplish. So with that, I'd love to turn it over to any questions that folks may have.
Thank you, Ian and Steve. If anyone has questions, you can type them into the Q&A window there. We have a couple to start with. We'll start with this one. Automation is the key in many modern factories. Are there any lessons that you are learning about how to make sure humans are being helped by technology instead of just always trying to keep up with technology, which can be stressful?
Yeah, I can go ahead and answer that one. Certainly I saw also there was a question, assuming humans are still part of the process. Of course, they very much are. I mean, one aspect of this that's very important is to make sure that the humans are aware of all of the data that they couldn't possibly digest in real time before, and to make that available much earlier in the process than it used to be. So people can see ahead of time, well, what's the effect if there's a temperature change, a pace change in an assembly line, something like that. We can show it in a model what the effect will be. Where humans can interact with the models rather than something physical, where if there's a mistake, obviously the cost of a physical mistake is much, much higher. So I'd say the biggest lesson learned of all of this is that digital really does make the humans' lives easier. It doesn't necessarily mean that we are trying to downsize the number of humans in the organization. It's more the humans that we do have can work on less menial things. They can be involved in making more complex machines without having to memorize every single data element or read them on a piece of paper. Rather, they can deal with something visual, something tangible, something that's interactive long, long before we have an actual physical part in the real world.
All right, thanks. Next question. What is the size of your staff that put this digital factory environment together, and how are third parties used?
So basically for each one of our business areas, we have about 15 to 20 people that are supporting. That includes both the kind of architecture for the overall solution. It includes the deployment of all of our edge processing. It includes bringing online all those different types of industrial control devices. Basically identifying what are the right drivers, what are the right ways of connecting to those systems. And so when you talk about third parties, there's third parties that we use to bring the data in. We talked a little bit about Kepware and how we leverage it for connecting those systems. We talked a little bit about AWS and how we use them to basically stream our data in and process it in a hot, cold, and warm type of environment. And then, oftentimes what you'll find is you may not always have the right skill set at each one of the locations that you belong to, but you oftentimes have to kind of reach out and get some support there. So oftentimes we'll do regional support, contract that out to kind of help the teams keep rolling and moving.
All right, thanks. We have time for one more, maybe two. Next question, which I love the way this one's worded. Do security threats keep you awake at night?
Well, I have an infrastructure job. My focus is mostly on the network and on the systems that we have internally. So do they keep me up at night? I get a phone call at night every now and then to make sure that this something isn't what it doesn't appear to be or anything like that. But in general, we try to be very proactive about these sorts of things. We are, like anyone else in this space, we are under constant attack, under the threat of all kinds of different groups, different opportunists, and so on. But we really have made to security a focus of any of our digital efforts here. Awareness is a big part of it. We assume that any part of the environment will have something go wrong with it at some point. There are going to be times where someone will get into a place that they're not supposed to. The key there, though, is to make sure that they can't get any further than one step in. Does it keep us up at night? No, it's just a part of our job that we have to stay on top of all the time. So part of making an intelligent factory is to make sure that security is baked in everywhere. That's not something we can put around the outside and have a bubble of security that if breached, everything inside falls apart. There's security at every layer along the way to check against all types of threats.
Okay.
Steve, do you want to add to that one, or?
The only thing I would add is, one of the key factors you find in the industrial control devices is a lot of them don't have security built in. These things were built 20, 30 years ago. And so there's no authentication mechanism, there's no scheme built there. So oftentimes what we do is we take these devices and we put them on isolated networks and we firewall them off in order to protect them. Because we know that there have been attacks in the IIoT space. We know adversaries like to use it to try and gain command and control, both on the network and associated devices. So we spend a significant amount of time locking down that environment to ensure that it operates well and runs with the lowest amount of risk.
Okay, is that all we have time for? All right, thanks guys.
Thank you.
Thank you.